Okay, so in this video, we are going to look at solving inequalities. Solving inequalities is similar to solving equations. There's just an extra step that we need to complete. What I want to make a note of is there's something special with the inequalities. So if we multiply or divide by a negative, then we are going to flip the inequality. So if we multiply or divide on both sides, by a negative, we flip the inequality. Okay, so that's super duper important. We have to remember that. Okay, because if we don't flip it, we're going to get the wrong answer. So the other piece is we're going to talk about open circles and closed circles. So we have these two inequalities, and I kind of like to think about it as, hey, they look like my left hand, so they're less than. So this is less than, and this one's less than. But if you notice on this one, it has the bar, so it's less than or equal to. So the less than look like my left hand. So that means the ones that face the other way have to be greater than or greater than and or equal to. Okay, so when we go to graph these, we're either going to use an open circle or a closed circle. So an open circle would mean that I am not going to include the number that my circle is on in my answer. So if I don't want to include it, I'm looking for a less than or a greater than sign. Those would be open circles. Now, if I want my answer to be equal to, then I want it to be included. So that means I color in my circle. So I'm going to color in my circle. So let's look at some examples. So our first example is negative 7x plus 3x is greater than 0. Sorry, is less than 0. So what I'm going to do, I'm going to combine my like terms like we would before. So I'm going to draw my line down, my inequality. So negative 7x plus 3x gives me negative 4x is less than 0. Okay, so now I'm going to divide by negative 4. Okay, I divided both sides by a negative. So that means I flip my inequality. These cancel like they normally would. So 0 divided by negative 4 is 0. So let's come over here and let's graph that. So 0, 1, 2, negative 1, negative 2. So I'm going to go to 0. I'm going to put an open circle because I don't want 0 to be in my answer. And then I have to read this. X is greater than 0. So what number is greater than 0? 1 or negative 1? Well, 1 is greater than 0. So I'm going to draw my line this way. That means every number bigger than that is an answer. Also, if you notice, my arrow points this way and my sign points this way. This only works if your variable is on the left. It does not work if your variable is on the right. Okay, so let's try another one. Okay, so in this one, I'm going to draw my line down. I have 20 is greater than or equal to negative 3x plus 7x. So I'm going to combine my like terms. Negative 3x plus 7x is 7x. I mean, it's 4x. So then I divide by 4. So 4 is not negative. I didn't divide by a negative, so I'm going to leave my sign the way it is. It gives me 5. Okay, so I have two options here. I can leave it like this or I can flip it. And you guys know that I like to flip it. So I'm going to flip it to say x. So right here, if I read this, 5 is greater than x. So I'm going to flip this sign so that it still reads that the 5 is bigger than x, or that x is less than 5. So if I come over to my number line, 5, 6, 4. In this case, I'm going to do a closed circle because 5 is an answer. It says x is less than 5. So what number is smaller than 5? 4 or 6? 4 is smaller. And if I look, my sign matches that one. So every answer this way. Again, it only works if your variable is on the left. Okay, so what if we get a little bit more complicated? So let's add the distributive property in here. Okay, so just like we would an equation, I'm going to distribute. So 5 times 1, 5. 5 times 4, 20x. It's greater than or equal to 105. Now I have my two-step equation, so minus 5. So I have 20x 100. So I'm going to divide by 20. Okay, 20 was positive when I divided by it, so I don't flip my inequality. So I'm getting x is greater than or equal to 5, so I'm going to draw my number line again. 5, 6, 4. It's going to be a closed circle. Okay, and x is bigger, so 6 is bigger than 5, so I'm going to draw it this way. Okay, so what if they put variables on both sides, which we did with equations? So let's look at a problem where I have variables on both sides. All right, so I'm going to start by combining my like terms. Draw my line down. 7 plus 5x. So on this side, I have like terms. I have a negative 3x and a positive 7x. That gives me positive 4x. And then you guys know I like the variable on the left, so I'm going to minus the 4x, minus the 4x. So that gives me 7 plus x, or 1x, is greater than 2. So I'm going to subtract the 7. So x is greater than negative 5. Yes, this answer is negative, but I did not flip my inequality sign because I did not multiply or divide both sides by the negative. So I'm going to draw my number line. Negative 5, 4, negative 6. Okay, it's not equal to, so open circle. And then x is bigger. So in this case, bigger would be negative 4. So my answer will go that way. So now what if they ask me to distribute twice and combine like terms? Well, we know how to do that. So let's say negative 27 is greater than negative 2, 8 minus 2x minus 3, 2x plus 1. Alrighty, so this one I got to distribute twice. That's okay, we know how to do that. So I'm going to draw my line down. So I'm going to say negative 2 times 8 and negative 2 times negative 2x. So negative 16 plus 4x. And then I got to distribute negative 3. So negative 3 times 2x, negative 6x minus 3. So combine my like terms. In this case, I have double sets of like terms. I have a negative 16 and a negative 3. So rewrite the left side, negative 27. So negative 16 minus 3 is negative 19. And then I have positive 4x minus 6x gives me negative 2x. Okay, so since there's no x on this side, I'm going to move the 19. So plus 19. Okay, so these cancel. So negative 27 plus 19 gives me negative 8. So then I'm going to divide by negative 2. I divided both sides by a negative, so I have to flip my inequality sign. Gives me positive 4. And then here's that situation where you guys know I don't like x on the right, so I'm going to flip it. So right now it's saying that 4 is bigger than x. So when I'm done, I want it to say the same thing. So x is less than or equal to 4. So 4, 5, 3. So at 4, I have a closed circle. And x is less than. 3 is smaller than 4. So I'm going to draw it that way. Okay, so we're going to look at 2 more examples. Okay. So -7, parentheses, -10x plus 10 minus 6 is greater than 10, parentheses, 7x plus 11 minus 1. Okay, so a lot of things to do here. First, I'm going to distribute. So -7 times -10, and then -7 times +10. So 70x minus 70 minus 6 is greater than 10 times 7, 70x, 10 times 11, 110 minus 1. So now I'm going to combine my like terms. -70, -6, -76, 70x. Okay, 110 minus 1 gives me 109. So now I'm going to move my x to the left because that's the direction I like my x's to be. So minus 70x. Uh-oh. My x's all disappeared. But wait, we talked about this. We could have different types of solutions. So I have to decide, is this a true statement? So -76 is greater than 109. Is that true? No. So no, it's not true. So I have no solution. So if I had a number line, my number line would be blank. So this is blank. I can't graph anything because there is no answer. Okay, so let's do one more problem. Okay, so I'm going to start by distributing. So I have 7x plus 70 plus 2x plus 20. I distribute again. 9x plus 90. So I'm going to combine my like terms. I have a 7x and a 2x. It gives me 9x. And a plus 70 and a plus 20 gives me plus 90. Okay, so I'm noticing my sides are the same right now. I'm going to move the variable to the left because that's where I like my variable. So I have 90 is less than or equal to 90. Well, 90 is not less than 90, but it is equal to 90. So we talked about another type of solution. So up here, this was not true. So we had no solution. 90 is less than or equal to 90. So this would be all real numbers. So what does that look like on a number line? So what that looks like on a number line, I'm just going to put 90 here. What that would look like is that my arrow would go all the way across in both directions because every number I pick would work. It would be all real numbers. So these are all of our inequalities with that extra added step.